Multiplication of matrices. In this lesson, you will learn how to multiply a matrix by a scalar and then find the sum or difference of scalar multiples and multiply two matrices. Now, besides adding and subtracting whole matrices, there are many situations in which we need to multiply a matrix by a constant. We call this constant a scalar. A scalar is a real number quantity that has magnitude but not direction. For example, time, temperature, and distance are scalar quantities. Now, the process of scalar multiplication involves multiplying each element in a matrix by a scalar. And a scalar multiple is any element of a matrix that results from scalar multiplication. For instance, we are given a matrix A here, and we want to find the scalar multiple CA, where C here is a real number. So to obtain the matrix CA, we just multiply each element of matrix A by C. Moreover, a scalar multiplication is distributive. So for instance, for matrices A, B, and C with scalars C and D, if you are finding, or if you want to find C times the quantity A plus B, this is also similar to finding CA first and CB and adding them. And also, C plus D times the matrix A is also equal to CA plus DA. To illustrate this, we consider the following example. Multiply matrix A by the scalar 4. So, to solve this, or to find 4A, we obtain this by multiplying each element in A by 4. So this is equal to 4 times 5, and then 4 times 3, 4 times 1, and then 4 times 2. And then simplifying this, we have 20, 12, 4, and 8. This would be your matrix 4A. Next example. Given matrix B, find negative 3B, where B is given by the matrix here. So to solve this, we will just have to multiply each entry in B by negative 3. So negative 3B is equal to negative 3 times 6, 0, negative 4. So you just copy matrix B. 3, 5, negative 4, 1. Now each entry in B will be multiplied by negative 3. So we have negative 3 times 6. So negative 3 times 6, negative 3 times 0, negative 3 times negative 4, negative 2 times negative 3 times negative 2, negative 3 times 1, negative 3 times 3, and negative 3 times 5, negative 3 times negative 4, negative 3 times 1. And then you simplify it. So simplifying this, we should get also a 3 by 3 matrix. So you have negative 18, 0, positive 12, 6, negative 3, negative 9, negative 15, positive 12, and negative 3. This is the matrix negative 3B. Next, let's find 3A plus B, where A is equal to this matrix here and B is this matrix. So to obtain this, let us first multiply 3, or let us find 3a first. And so we obtain that by multiplying each element in A by 3. So 3a is equal to 3 times the matrix A, negative 2, 1, 3, 8. And this is equal to negative 6, 3, 9, and 24. So just multiply each element in A by 3. Then after that, you add the matrix 3A to B. So the matrix 3A is negative 6, 3, 9, 24. Then add that to matrix B. This is your matrix B. So you just copy that. You have 4, negative 2, 0, 8. So in adding two matrices, you just add component-wise. So you do negative 6 plus 4. So that is equal to negative 2. And then 3 plus negative 2 is 1. And 9 plus 0 is 9. 24 plus 8 is 32. And so this is your matrix 3A plus B. Next example. Find the sum of 2A minus 4B, where A is given by this matrix and B is given by this matrix. So we will solve this by computing 2A first. So we'll find 2A first. And 2A is equal to 2 times the matrix A, 6, 4, negative 2, 3, 0, 1. And this is just equal to, just multiply each element in matrix A by 2. So 6 times 2 is 12, 4 times 2 is 8, negative 2 times 2 is negative 4, 3 times 2 is 6, 2 times 0 is 0, and 2 times 1 is 2. This is your matrix 2A. Next, we find 4B, the matrix 4B. Matrix 4B is 4 times the matrix B, negative 6, 1, 5, 7, 2, 0. We obtain this by multiplying each element in matrix B by 4. So you have 4 times negative 6 is negative 24. 4 times 1 is 4. 4 times 5 is 20. 4 times 7 is 28. 4 times 2 is 8. And 4 times 0 is 0. Then we subtract the two matrices to get 2A minus 4B. So 2A, copy matrix 2A, which is 12, 8, negative 4, 6, 0, 2. And then the matrix 4B is negative 24, 4, 20, 28, 8, 0. And then subtract the two matrices. So 12 minus negative 24 is positive 36. And 8 minus 4 is positive 4. Negative 4 minus 20 is negative 24. 6 minus 28 is negative 22. 0 minus 8 is negative 8. And 2 minus 0 is 2. So this matrix here is the matrix 2A minus 4B. In addition to multiplying a matrix by a scalar, we can also multiply two matrices. Finding the product of two matrices is only possible when the number of columns of the first matrix is equal to the number of rows of the second matrix. So if A is an M by R matrix and B is an R by N matrix, then the product of the two matrices, AB, is an M by N matrix. So for example, the product AB is possible because the number of columns in A is the same as the number of rows in B. If these dimensions do not match, then the product is not defined. Again, when you're multiplying two matrices, you have to make sure that the number of columns in the first matrix is equal to the number of rows in the second matrix. Take note that multiplication of matrices is not commutative. That means the product AB is not equal to the product BA. So the product of two matrices, say for instance AB, can be obtained by multiplying the elements in the rows by the elements in the column of the second matrix and add the product. So that means, for instance, the ijth entry of the product of the matrix AB, the product of the two matrices A and B, is equal or can be obtained by multiplying the entries in row I of matrix A by the column entries in the jth column entries in B, and then add the product. So to illustrate this, let us consider the following matrices. We want to find the product of the matrix AB. Now, to obtain the element in row 1, column 1 of AB, multiply the elements in the first row in A by their corresponding elements in the first column in B, and then add. So that means this will be multiplied to this element, and this element will be multiplied to this element, and this element will be multiplied to this element, and then you add all the products. And similarly, to obtain the element in row 1, column 2 of AB, multiply the elements in the first row in A by their corresponding elements in the second column in B, and then add the product. So that is multiply A sub 1 1 to B sub 1 2, and then A sub 1 2, multiply that to B sub 2 2, and A sub 1 3 is multiplied to B sub 3 2, and then add the product. And using in the same manner, we obtain the element in row 1, column 3 of AB by multiplying the elements of the first row in A by their corresponding elements in the third column, and then add the product. And we proceed the same way to obtain the second row of AB. In other words, row 2 of A times column 1 of B, row 2 of A times column 2 of B, row 3 of A times column 3 of B. And when complete, the product of the matrix will be equal to this. And then just add all the entries. And as a general note, take note that matrix multiplication is associative and also distributive. So associative, that means if you multiply A, B times C, that is also the same as multiplying the matrices B, C first, then multiply the product to A. And also it is distributive over addition. So C times A plus B is equal to CA plus CB. and A plus B, quantity A plus B times C is, you can distribute C to each of the matrices here. And just take note that matrix multiplication is not commutative. So that means these two matrices here are not the same. Or AB, the product AB is not the same as the product BA. So to illustrate multiplication of matrices, let's consider the following example. Find the product AB. Now, before you find the product AB, you have to make sure to check first the dimension of the given matrix. So matrix A here is a 2 by 2 matrix, and matrix B is also a 2 by 2 matrix. And then before you proceed, you make sure that the number of columns on the first matrix is equal to the number of rows in the second matrix. Since both of these two matrices are 2 by 2 matrix, then the product of the two matrices is possible to obtain. Now, to get the product AB, all you need to do is multiply the entries in row 1 of A to the first column entries in matrix B. So you multiply corresponding entries. So 3 times 6. So you have 3 times 6. And then add this to the product of 2 times 8. So 2 times 8. That is your first row, first column entry in the product AB. And similarly, to get the row 1, second column entry in the product AB, you multiply the first row in A by the second column in B. And you multiply element-wise. So the entries, or the corresponding entries. So multiply the corresponding entries. So 3 times 7. And then add the product. So plus 2 times 5. These are your first row entries. And then to obtain the second row entries, you multiply the corresponding entries in the second row by the first column in B. So first row in A by the second row in A by the first column in B. And then you multiply the corresponding elements. So 1 times 6, 1 times 6 plus 4 times 8. That is your second row, first column entry in the product AB. And then next, you multiply the second row by the second column, first row in A by the second column in B. So you have 1 times 7 plus 4 times 5. And then you simplify. So you get the product and add them. So you have 18 plus 16. So you have 18 plus 16. And then 21 plus 10. And then 6 times 32. 7 times 20. Then simplify it. So we have 18 plus 16 is equal to 34. And then 21 plus 10 is 31. And then 6 plus 32 is 38. 7 plus 20 is 27. This is the product of the two matrices AB. So this is your matrix AB. Another example, multiply matrix A and matrix B, or find matrix AB. Now, before you proceed, you make sure to examine the dimension of the given matrices. Matrix A is 2 by 3 matrix, 2 rows, 3 columns. And matrix B is 3 rows, 3 by 2 columns. Now, note that the number of rows or the number of columns in matrix A is equal to the number of rows in matrix B. So since the number of columns in matrix A is equal to the number of rows in matrix B, then multiplication or the product AB is possible. So AB, matrix AB, can be obtained by first multiplying. So the first entry in the first row in AB is obtained by multiplying the elements here to the elements here. You multiply corresponding elements. So negative 6 times negative 1. And 1 times 4. 1 times 4, and then you add that. So you add all these products. So plus 0 times 3. And then you do the same thing for the second entry. So you multiply the first row by the second column here. So you have negative 6 times 8 plus 1 times 6 plus 0 times negative 2. And then for the second row entries, you multiply the second row in A by the first column in B. So you have 4 times negative 1 plus negative 3 times 4 plus 2 times 3. And then to obtain the element in row 2, column 2, you multiply row 2 entries times column 2 entries and add the product. So you have 4 times 8, negative 3 times 6, and 2, and then you add plus 2 times negative 2. So you make sure you add all the products here. Then you simplify. You have, so negative 6 times negative 1 is positive 6 plus 4 plus 0. And you have negative 4 minus 12 plus 6. Negative 48 plus 6 plus 0. And positive 32. So 4 times 8. 4 times 8 is 32. And negative 3 times 6 is negative 18. 2 times negative 2 is negative 4. And then you simplify. So 6 plus 4 is 10. Negative 48 plus 6 is negative 42. And negative 4 minus 12 is negative 16 plus 6 is negative 10. And 32 minus 18 is 14 minus 4 is equal to 10. So this is the matrix AB. As you could see here, the resulting matrix has a dimension of 2 by 2.